Hello YouTubers, Waycool here, and today I'm going to look at scientific notations. Now we need to know exactly what is scientific notations. Here is a definition. Scientific notation also refers to as standard form or standard index form, is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. It is commonly used by scientists, mathematicians, and engineers, in part because it can simplify certain arithmetic operations. Basically, to newbies, that may sound like a bunch of gibberish, so we will definitely try our best to let you understand by simplifying or break down exactly what we're saying in this definition. Some examples of scientific notations are as follows. Now, these are different examples of how you can represent scientific notations. We will explain each term and so that you will understand exactly how to write each scientific notations. And whenever you calculate these or simplify these scientific notations, you will know what form the answer should be in. We will now look at the general scientific notation format. Here's an example. We have 2.50 times 10 to the power of 9. To explain each section, or to let you understand each part, the 2 would represent a whole number, and this whole number can be a negative or positive whole number between 1 and 9. Then we have a decimal point followed by the decimal number. We have to include the multiplication sign, base 10, and some power or exponent. And this power or exponent can also be a positive or negative whole number. So that's the general format. When working with scientific notations, the whole numbers must be a positive or negative number between 1 and 9. How to write 345 in decimal format? This can be done by dividing 345 by 100, and this will equal to 3.45. This can also be written another way, just like this, that I'm sure most of you out there will understand. Now, why did we choose 100? Well, the reason for this is because we wanted the number to be in the correct decimal format so that we can use it in our scientific notation. Please note that based upon what we have said before, when working with scientific notations, the whole number must be a positive or a negative number between 1 and 9. So that is the reason why we choose 100, so that we can get this positive whole number to be between 1 and 9. Okay, we are going to use the same number in an example to show how we can move the decimal place so that we can get the number in the correct decimal format to use in our scientific notation. To achieve this, we will start with where the decimal point should be. And in every positive or negative whole number, we have an invisible decimal placeholder. Now, this is our starting point. All right, from here, we are going to move this decimal point one place to the left each time. until we reach our desired location. Each loop will represent the movement of the decimal place and each power in our base 10. So here we have our base 10 to the power of 1 for the first loop and our base 10 to the power of 2 for our second loop. Please note that with a whole number larger than 1, moving the decimal point to the left will yield a positive power of 10. Thus, we have a positive 1 and a positive 2. Okay, so now the amount of space that you move the decimal point to the left or to the right, that's the power of 10. So that's what we just talked about right here. So what we have is 345. Moving the decimal point 2 places to the left, we have 3.45. This is equal to 3.45 times 100. Or it could also equal to 3.45 times 10 to the power of 2. Now, which one of these format do you think represent our scientific notations? Well, obviously, the answer is clear. It is the 3.45 times 10 to the power of 2. That is our scientific notation form. And that is how we need to represent it given an exam or a test or otherwise. So now this term right here would be incorrect. So we have to throw away this. Okay? How to write 0.345 in scientific notation form? Please note that with numbers smaller than 1, moving the decimal point to the right will yield a negative power of 10. This we can look at with an example. Now this example is similar to the one that we just did. Alright, but in this case we're going to use a number that is smaller than 1. It is 0.345. Now this number already shows the decimal place. Alright, we're going to move that decimal point 1 place to the right, thus resulting in a base 10 with a negative power of 1. Okay, so we will have from this 3.45 times 10 to the minus 1, and that will be our scientific notation. Very simple. Alright, so we had to only move it 1 place to get it into the correct decimal format so that we can get our scientific notation. Okay, there you have it. I will be doing some more examples in future videos. But for now, I need you to take a look at these 4 numbers that were converted to scientific notations. Please note the difference. They are not the same, so I don't want you to be confused. I hope this helps. Thank you and goodbye.